Alright guys, so in this problem we have to find the height of the tower. This is what we're going to do. Looking at this problem, what do you notice about this? The fact that there's a small square at the bottom of one of the triangles, that tells you that this triangle is a 90-degree triangle or a right triangle. What this also tells you is that if you look at the bigger triangle, which starts from this point all the way up at the top of the tower and then goes all the way at the bottom of the building, comes back down, this is also a 90-degree triangle. The reason why this is important is because you can always apply right triangle trigonometry or SOHCAHTOA to solve problems dealing with right triangles. This is what we're going to do. Since you're asked to solve for the height of this, we can call that y if you want, or any of the other variables that you want to select. This is what I would personally do. I'm going to look at this triangle, the bigger triangle, so we're going to say that you have this thing. Okay, let's fix that a little bit. So you got the problem that looks like this. We're going to take the 15.9 degrees and the 23.6 degrees, and we're going to add those two values up to get the total on this. Now, look on the calculator on the right to see how that would be done. 15.9 plus 23.6 degrees. Add that up and press the enter key, and that's going to give you 39.5 degrees. So this angle is equal to 39.5 degrees, and then you know that the base of the triangle is 200 meters, or that's the distance from the bottom all the way to the bottom of the building. Okay, so you got 200 meters on this. What we can do at this point is that we can actually use right triangle trigonometry, since we know that this is right triangle, to find this overall distance. Okay, so you can say that that's the height from this point all the way to the top. Okay, so since we've already drawn the triangle out, we know that that's these 2 points right here. Now, how do you actually solve for the overall height? Well, this is what we're going to do. This is the angle that you're given. You can see that the side that's opposite to this is the h, and the side that's adjacent to this is 200 meters. And since this is a 90-degree triangle or a right triangle, we can say that tangent of 39.5 degrees is equal to opposite, which in this case is h, over the adjacent, which is 200 meters. Now keep this in mind, guys, we're working with degrees, so you want to make sure that the calculator is set in degrees. Now again, on TI-83s, TI-84s, it's real easy. You go in the settings menu and you want to make sure that you are in degrees if the problem is given in degrees, and which in this case is not an issue because you can see that we're in degrees. So second quit, let's go back to the home page. How are we going to actually solve for this? Well, I would personally do this. Let's put in tangent of 39.5 degrees, close the parentheses, hit the enter key, and that's going to give you 0.824 on the left hand side of the equation, which is equal to h over 200. Now to get the h by itself, we're going to need to multiply both sides of the equation by 200. 0.824. Once you multiply it on the right, the 200 cancels out, so we don't have to write that out. Multiply this by 200, and that's going to give you 0.824. That's going to give you 164.8 meters. But keep in mind though, this is not the height that they were asking for. This is the overall height. So let me just go back to the original problem that was given. This is the height that we actually just solved for. So that's equal to 164.8 meters. But what we can do is, since we're asked to solve for the height of the tower, what we're going to do is we're going to need to subtract whatever this comes out to. Okay, once you subtract this from the total, which is 164.8, you can get the remaining height of the tower. So how do you actually do that? Well, let's actually zoom in a little bit on this, and I'm going to zoom out in a second. You can see that this is also a right triangle. So that's a right triangle as well. And what that tells you is that since you know the angle over on this side, just like in the previous triangle, and you know that the base of the triangle is 200 meters, you can use right triangle trigonometry to solve for the height for this specific triangle, or the height of the building. So this is what we're going to do. Let's zoom out and draw this triangle out. Okay, so now you have the second triangle, which is also a right triangle, and this is 23.6 degrees. The reason why it's a right triangle is because of the 90-degree angle that's given. And then, of course, this itself is 200 meters. You're going to see that a lot of times, you're going to have problems dealing with triangles where you're going to have multiple triangles combined into one, but you can always use the same measurement for different triangles. For example, you saw how we used 200 meters for the bigger triangle, but then we can also apply that same value for this one, since they both have that common side. Now, we're solving for this height. So again, since we've already used h, we can call this a different letter. So let's just call that, we're going to call that c. Again, it's really up to you, whatever you want to call that. Since we're solving for c, you know, the relationship still is the same, opposite, adjacent, so we know that we're going to be using the tangent function. The only difference now is that the angle is not going to be 39.5 degrees as in the previous example. It's actually going to be 23.6 degrees, and that's going to be equal to opposite, which is c, over the adjacent, which is 200 meters. Again, you know, make sure that it's in degrees, but we've already checked that, so we don't need to worry about that. Tangent of 23.6, you know, close the parentheses, press the enter key, and you get 0.437 if you round that to 3 decimal places. 0.437 just for the tangent itself, and that's equal to c over 200. Let's scroll up just a little bit. Alright guys, since we're solving for c, we're going to need to multiply both sides of the equations by 200. Okay, and what's going to happen is that on the right, the 200 cancels out, and the only thing that you're going to be left with would be the c. So 200 times 0.437, that's going to give me 87.4, and since the original units were in meters, you want to make sure you put that. Alright guys, again, this is still not the final answer, but we're almost there, you know. So what exactly does this answer represent? Okay, so you got 87.4. Let's actually go to the original problem that they gave us. So the 87.4, you know, we're going to zoom in on this. Okay, the 87.4 is this height. Let me just relabel this. Okay, so that's the height of the building. This is equal to 87.4 meters. Now, since you know that the overall height came out to 164.8 and this came out to 87.4, you can solve for the remaining height, which is the height of the tower, by subtracting 87.4 from the 164.8, and that's the answer that you're looking for. So let's actually put that in the calculator. 164.8 minus 87.4. Press the enter key and you get 77.4. Alright guys, so that's the answer in this problem, and we can say that the height of the tower is, you know, which we were calling y, I believe, in the, you know, in the beginning of the problem. So we'll say that y is equal to 77.4 meters. But again, you can use whichever variables you want, guys. Alright, that's the end of the problem.